Dr. Peter Nightingale, professor at University of Rhode Island. Always a pleasure to have you on. We are talking today about the warfare state and the particular odd and important role that little Rhode Island inconspicuously but importantly plays in that system.
Yes. Actually, I've been retired for a little over 2 years, but I'm still an emeritus professor at URI, so I have some rights there that most people don't have, including perhaps last rights. Who knows? Um, and maybe I should backtrack a little bit. I'm a theoretical physicist, and I'm a thoroughly secular person. But in terms of original sin, I think that nuclear weapons are as close to that as anything gets. So that's how I got into this, and I've been fascinated by these things since I was about 15 years old. But let me make a few comments about Rhode Island being at the center of the war economy, or express it any way you want. And I thought, how can I quantify that? After all, I'm a physicist, so I like quantifying things. Well, there are four things that I came up with. There are non-proliferation experts, people who are pushing back against things that have been happening for many years and are happening as we speak. And I think that it's fair to say that our US senators are number one on their list of people who are doing stuff that they shouldn't be doing. Um, so that's sort of a joke, but that's rank number one. I think that's fair. If the Pentagon publishes numbers, and they're very difficult to read because they're very incomplete. They use definitions that we don't know, so they leave things off, et cetera, et cetera. But they provide a measure. And if you go by those, if you look at Pentagon dollars per capita in Rhode Island ranks number 5 in the US. So that's pretty high up there, I would say. Um, if you look at, again, coming back to those US senators per capita, well, we all know that the US Senate is not really representative in any way. But on that scale, we're number 7. So we're pretty high on that list, too. If you look at the number of Pentagon employees per capita, another measure, we're number 14. That's not quite as high, but that's still pretty high. And I think um, if you want to summarize it in more traditional metrics, about 10% of the Rhode Island economy is war economy. So it's an important part of who we are. So that, yeah, well,
Okay, so we began with the tearing. Let's talk about uh, the next topic. I believe was the Rhode Island delegation in particular, and what uh, shortcomings they demonstrate repeatedly.
we can start there, or we can start with the URI reactor, which,
Okay.
I mean, in some sense, I would prefer that because I can explain what some of the issues are, and once we know what the issues are, it might be easier to explain where the members of the congressional delegation stand, if that's okay with you.
Beautiful.
I have quite a few things to say about the reactor. Some of it is physics, and if I go too far into that stuff, then just rescue me from the weeds. That's fine. We can interrupt that. Well, anyway, the history of the URI reactor is that it started operation in 1964. That was in the middle of the Cold War. And in those days, a lot of research reactors used highly enriched uranium, bomb grade uranium. And that's sort of hard to believe for us these days, but that's how it was. And that practice that goes back actually to the Eisenhower days, when Eisenhower and his crew instituted something called Atoms for Peace, and they were spreading highly enriched uranium, bomb-grade uranium, across the globe as if there is no tomorrow. And actually, it's surprising that there still is a tomorrow if you go back to that. So one of the things that I will come back to is that Atoms for Peace, as I see it, has an evil Siamese twin, which we can call Atoms for War. You cannot separate the two, and people don't want to go there, but that's something that has been known since 1946. But we'll get back to that. Well, what happened is that at some point, India in 1974 set off a nuclear test. And that came as a real shock to people. China had done it 10 years earlier, but somehow it took more than one wake-up call to alert people. So after that, the US government said, hey, we can't have this bomb-grade material floating around the world. That's too much of a risk. So we're going to scale those reactors back to 20%, which is still high. And even today, the discussion is still around whether 20% enrichment is enough to make bombs. But it's not the standard procedure, and you have to do it carefully. I think that it took until 1974 before people discovered what was going on is what I would call a cognitive illusion. I don't know whether people have seen the Oppenheimer movie, but at some point, Oppenheimer visits what's his name? Truman in his office, and Truman says, "So when do you think that the Soviets will have a bomb?" And Oppenheimer doesn't know what to say, and so Truman jumps in and says, "Never."
Right.
Well,
Right.
took about 3 years, and surprise, surprise, the Soviets had caught up, and then England and France, et cetera, all caught on. And I think that people were misled by the fact that the original process of creating bombs in the US was extremely difficult. And they thought nobody else can do that, nobody can have the industry. And that simply changed. It became much easier and has become almost pedestrian. And as a consequence, I think of that same kind of illusion, US spooks seriously underestimated the Chinese capabilities. Um, and the same is true about the Russians. And there's an interesting article that a guy at MIT wrote, R. Scott Kemp. It's called "The Non-Proliferation Emperor Has No Clothes." In other words, you say, look, you are saying, let's limit the technology and nobody can follow. And his argument is, well, things have become so much easier that a lot of people can do it. Not quite in your or my basement, but still close enough.
Well,
So,
I mean, famously in the 1990s, do you remember there was a book called The Radioactive Boy Scout?
oh, I don't remember that. No, no.
Oh, this was a newspaper story. It was in Reader's Digest, and it was about a Boy Scout who collected enough uranium or plutonium or something out of, I think it was watch batteries, calculators, and other odd sod early 1990s electronic components, and created a radioactive fission reactor in his backyard that required the atomic agency to come out and actually shut the damn thing down.
I had never heard that, but so actually I said not quite in your basement, but apparently even that is no longer true. It wasn't true then. Well,
Right.
it's really important in particular when you hear all this talk about Iran and what people say, and we bomb them back to the Middle Ages, or well, they didn't quite say that, but something like that. It's nonsense. It's real nonsense. It's dangerous nonsense.
Right.
Anyway, however that is, um, you were wondering about can you harvest plutonium from the URI kind of reactor? And the answer is nothing is impossible, but it's not very likely, not a very likely path. And in order to explain that in more detail, and let me say, nothing is uncontroversial in this field. If you say that something can't be done, somebody gets up and does it, roughly speaking.
Right.
so, so One of the things that make it hard to follow this whole business is all these acronyms that people use. LEU, HALEU. I don't even know how to pronounce it. HEU. So I'm going to use three categories: low enriched uranium, which contains material that is used in reactors. That means that the part that is really can sustain a chain reaction, uranium 238. I'll come back to that in more detail.
Yep.
There's less than 5% of that. There is medium, they have a really bizarre name for that, high assay, low enriched uranium, which is contradictory. High assay means it has a lot of that stuff in it, and low enriched means it has little in it. So go figure. I call it medium, between 5 and 20%, and higher than 20%, which is called high enriched. And the number 20% comes from the fact that people thought if you have the explosive uranium more than 20%, you can make a bomb. As I mentioned before, the discussion about that, whether it's 12% or 20%, is still raging as we speak, but that's the standard terminology. So low, medium, high, whatever. Okay, so let me describe what the conundrum is with plutonium, because it is a dangerous material, but it's not totally trivial to deal with. So let's go back to basics. Atoms consist of a nucleus, and around the nucleus is an electron cloud. The nucleus is important for nuclear physics, obviously, and the electrons are important for chemistry. All the chemical properties are determined by the electrons, certainly for the heavier metals. If you're talking about hydrogen, it's a little bit different, but we're not going to talk about that. So in the nucleus, you have protons, they're positive, and there are neutrons, they're neutral, and the electron cloud is negative, so the whole is neutral. And as I mentioned, the chemical properties are defined by the electron cloud. Now, if you have a fixed number of protons, you determine the chemical properties of that metal because the number of electrons is the same, and that determines the chemistry. But you can add neutrons or subtract neutrons without changing the chemical nature of the atom. So the most abundant form of uranium is called uranium 238. 238 is the sum of the number of protons and neutrons in the nucleus. So there are 238 of those, and the technical term is that uranium 238 is what is called fissionable, but it's not fissile. Fissionable means if you hit it with a sledgehammer, it will break apart, and the parts will fly apart with more energy than you stuck into it. So it produces energy, but it doesn't produce enough neutrons to sustain a chain reaction. Uranium 35 produces neutrons, and those neutrons go on and hit other nuclei 235, and then you get one neutron and then two neutrons, and the two that break generate four neutrons, and you have a chain reaction: 1, 2, 4, 8, boom. So 238 will do that. 235, uranium 235 will do that. Uranium 238 will not. But if you have an explosion and you surround it by uranium 235, as they do in thermonuclear bombs, then the uranium 238 will be hit and will split and will add to the bang. So
it's an enhancement in that instance. Are you saying?
yes,
Okay.
it plays several roles. They do it to hold. See, the thing is, if you set off a nuclear bomb, if the reaction starts slowly, what you get is a fizzle. The bomb destroys itself before it fully explodes. And in order to slow down that process, you put something heavy around it. And if that something heavy adds to the explosion, so much better. So that's why they use um, why they wrap those bombs in uranium-238,
Right.
or even completely depleted uranium, which has no 235 or very, very, very little.
So let me ask you if this is a fitting analogy. It's not perfect, but let's say if you're talking about, I don't know, a stick of dynamite and then you wrap it in a bag of gunpowder. Is that equivalency where I'm going?
Uh,
Or dip it in a thing of gasoline?
well, I would say you do two things. One is you wrap it in some piece of metal that makes sure that the reaction is really going, and then around that you put a layer of something else that explodes, and then the whole thing will be more explosive than just the core of that. So keeping the thing
Gotcha.
together so that it really, really burns helps enhance the explosion. And it also
Gotcha.
helps to create a shock wave.
Right.
So yes, it's sort of that. So now the issue is with, as I said, if you have different isotopes. Isotope means the chemical properties are the same because the number of electrons are the same, number of protons are the same, but the number of neutrons are different. Then the weight of those nuclei is different, but the difference in weight is very, very slight, and that is what you have to use to separate the 235 from the 238. It's what the enrichment does. And so you have to use physical properties, like how quickly does something diffuse. Heavy people walk slower than light people typically. And the same is true for nuclei, except the difference is very not even a percent in weight. So the difference in speed is very small, but that's what you need in order to separate um, the 238 from the 235. Now, the other thing that happens is as you have a nuclear reactor, which of course is not exploding, or it has mechanisms in there that keep it on the hairy edge between explosion and not doing anything. That is an environment in which there are a lot of neutrons flying around. And if a 238 nucleus is hit by a neutron, then sometimes that neutron will be absorbed, and then you get something that is unstable and it spits out an electron. And I'm talking about the nucleus. So the nucleus spits out an electron. Charge is never created, it's always constant. So that means that at the same time, a proton is born. And if a proton is born, that means that the outer shell of this nucleus is a different one. It's called neptunium, and that neptunium is not very stable. It gives rise to plutonium. So so you start with uranium 238. You add a neutron, then you get uranium 239, which is not stable at all, and then that generates neptunium, and the neptunium produces plutonium. If you have that plutonium in the core of a reactor, such as the URI reactor, then that plutonium 239 will absorb yet another neutron and become plutonium 240. And 240 is more reactive than 239. Both of them are fissile. In other words, if you take enough of that stuff together, they can sustain a nuclear reaction. But the problem with plutonium 240 is that it's very reactive, and therefore it's very difficult to assemble something that really says bang rather than destroys itself before it explodes. So, in practical terms, um, plutonium 239 can be used to make bombs, but even that is difficult because it tends to generate neutrons. And the way they solved that in Big Boy, the bomb that destroyed Nagasaki, is they had a complicated construction that took pieces of plutonium and shot them together so fast that before the thing knew what was happening to it, it was super critical and it really said bang. If somebody had just put those pieces together by hand, which is not a healthy thing to do. But other than that, it would have given you what people in the trade call a fizzle. So you don't get much bang for your buck. So the plutonium that sits in a reactor like the URI one is contaminated by plutonium-240, which makes it not a very good material for making bombs. So in that sense, those kinds of reactors are not much of a danger in terms of that somebody can take the plutonium and make a bomb. You have to be much more sophisticated than that. Well, there was a lot of stuff. So basically, you start with uranium, you end up with plutonium, two kinds. One is bomb grade stuff, and the other is not bomb grade stuff. And as time goes on, more of the non-bomb grade stuff accumulates, which poisons the usefulness. So in that sense, I'm not that afraid of the nuclear reactor at URI. Now, as I said, nothing is completely, totally true. So at some point, there was an experiment that the US claimed to have done where they exploded a plutonium bomb that had a lot of 240 in it. How much is classified, but much more than the typical bomb maker likes. Now, it's classified, so God only knows whether they're playing poker and lying or whether it's true. I think it's probably mostly true, but anyway. So that's sort of an answer to the question, well, how about the danger of the plutonium at URI or certain reactors like that? Now, the other thing is, well, how then do you get plutonium for bombs? Well, basically, you have to create the reactor so that it can produce that. Basically, you have a little window in there, and you stick some uranium-238 in there and take it out after a couple of weeks, and then you don't have a lot of plutonium-240 in there. Most of it is then 239, and that's bomb grade material. But the thing has to be designed to do that, and obviously the URI reactor and its kind, it doesn't do that. So that's I think the full story.
Gotcha.
Okay, well, with all these things, I don't know who this was, but one of the directors of one of the national labs said something like, simple nuclear bombs are easier to construct than most think. And the reverse is also true. Sophisticated nuclear bombs are much more difficult to construct than most think. And so plutonium bombs are sophisticated. Uranium bombs are not. And that shows up because the bomb that destroyed Hiroshima, little boy, had never been tested. They were so confident that it would work that they just did it and used it as the first one. They weren't all that sure about the second one, which was a plutonium bomb with the implosion where everything came together. That one worked also, but that one had tested. You know, the famous Trinity test in July, was it 16 of 1945. I don't know, but there's one thing that maybe I should mention.
Sure.
But if you think that we're spending too much time on this, we can move on. But
No,
but
keep going. This is great.
Okay, good. So if you talk about the effort that goes into enriching uranium, so uranium, as it is found in nature, has less than 1% uranium-235, the explosive stuff in it. And the rest is mostly 238, although there are a couple of other things that are so small that nobody ever mentions them. So if you look at a typical reactor like well, not like the URI reactor, but a reactor that is used to generate steam, a water boiler, in other words, for generating electricity, those typically run on uranium enriched to about 5%, 4 to 5%. And you ask yourself, well, okay, if I have that kind of stuff, how much more enrichment do I have to do? How much more effort do I have to do in order to get to bomb grade? And you would say, well, from 4% to 90%, That's quite a way.
Hmm.
Uh, as a matter of fact, this is something that even nuclear engineers, as my experience, don't know, but that's completely incorrect. Um, if you are at about 2.5% enrichment, which is about half of what people use for electricity generating reactors. If you're at 2.5%, you have done half of the work that needs to be done to get up to 90%. That's very counterintuitive. If you, for instance, get to where Iran is at the moment, 60%, you're somewhat above having done 93% of the work that needs to be done. So once you hear that Iran has enriched up to 60%, you should start scratching your head and say, what are they doing? There are two possibilities. Either they're on the way of making a bomb, or they're playing poker with the US. And they could do both. Play poker, hoping that they get something out of it and don't have to continue. I don't know. And I don't think that anybody knows, other than that right now there is a fatwa that the clerics have issued that they're not going to make a bomb. I think that fatwas are pretty fragile things that I don't want to hang my fate on.
I
So
can give my own take on this point because I've actually followed it. I think, particularly in the Islamic world, it's uh, not a taboo topic to talk about the fate of Muammar Gaddafi after he gave up his nuclear program. And so the kind of conventional wisdom emerging, and this is something you also see with North Korea, is they see their nuclear bomb program actually as a deterrence. And, you know, as a left winger, I mean, I'm not necessarily endorsing this view, but I will note that Alexander Coburn used to say that every country in the world was entitled to one nuclear bomb just so that way everybody had parity. So,
it's a tough one, and John Mersheimer, I don't know whether you follow him on
yeah,
Facebook.
oh, yeah.
Well, he has said it was a very big mistake that Iran didn't make its bomb because now they're paying the price for it. And I know from people who understand what's going on in that country that there is a big discussion going. Should we or shouldn't we? And I don't know which way it's going to work out. And anybody who tells me that he or she knows, I don't believe, because that can change overnight.
Right,
And if you're at
right.
93% of the work that needs to be done, then it's very easy to do the rest. And so this whole discussion about the CIA saying, oh, well, they're not making a bomb, I don't believe a word of it. I mean, we know how they missed the boat on China, on Russia, and or on the Soviet Union at the time. And now we have to believe them? I don't think so.
Right. And that even speaks, I think it leads into a useful just side point is the fact that uh, Putin is the president that's had the closest relations with Iran in an entire century. And along with China, I mean, it's very easy for any of the old Soviet warheads to just be sold to another country by Putin. I mean, we remember at the end of the Cold War, there was all this talk about, oh my God, that now there's like 100 gazillion warheads all over the former Soviet Union, and you could end up having them in the hands of either an international terrorist or an oligarch gangster or maybe a couple people pooling together their resources because they were strip mining the place after the fall of the Soviet Union, and that was part of their infrastructure.
Well, that is true, and we think that we're doing better, but I don't remember which book it was. Command and Control, I think. Did you read that? I don't remember
No, no, no.
huh? Well, I'm pretty sure that I read in there that he did a survey of how much control there was of the bombs that were in Italy and all over the place in Europe in those days. And so occasionally they just went for a couple of drinks and left the door open. I'm not
Well,
necessarily literally, but not very different than that. So, somebody walked in and took one of them, they would have probably noticed. But I don't know. The more of this stuff you have lying around, chances that something goes wrong increase. And there is the old law that says that what is Murphy's law? If something can go wrong, ultimately it will go wrong, which is simple mathematics. It's nothing metaphysical. But anyway, um,
Absolutely.
well,
But he
so does that sort of answer your issue about the risk of reactors like the one at URI?
truly does. It's very interesting and helpful. Um, just one further question. What's your thought on, even if it isn't producing material that can be of grade for bombs or anything, applications of whatever research is done on the campus in military settings or applications? Have you ever seen any sort of overlay with a federal or military agency interests?
I I I think but I've been talking to people who have always been real scientists or interested in climate change and things like that. People at GSO, they tend not to be working for the military, and occasionally I'm sure they get funding, but then they don't talk about it. So my view might be very colored by simply talking to the wrong people. But my impression is that that is an honest research reactor. And if you ask,
Gotcha.
okay, should we do away with them because you have the knowledge for one, you can create the knowledge for the other? I say yes, that's true. I don't know what you're going to sacrifice if you were to do away with all of it. I can only say one thing. There was one guy at the Manhattan Project, Joseph Rothblatt. Does that name mean anything to you?
Doesn't jump out, but I've studied the Manhattan Project plenty.
Well, Joseph Rothblatt was a unique character in that he was the one scientist who left the Manhattan Project. I think it was sort of December of 1944 when it was clear that the Germans were losing the war. And he came from a sort of not quite pacifist, but relatively pacifist, if there is such a thing, background, and had serious reservations of joining. And the only reason why he did join, and he came up from Poland, was he said, well, if somebody like Hitler gets a bomb, he has no scruples and they'll use it. And so I have to work on it. And then when it was clear that the Germans were losing, he was at a party and heard what's his name, Leslie Groves, the guy who
Yeah,
was
yeah.
the military guy in charge of the Pentagon project, say, as soon as I had been here for about 2 weeks, here meaning Los Alamos, I realized that the bomb was being developed not against the Nazis but against the Soviets.
Yeah.
And Rothblatt was really, really shocked by that. He said, "These
Right.
are our allies, and that's what you're doing."
Right.
And he he asked permission to leave, and he did leave. The condition was, you keep your mouth shut. We are just going to say you are going to go back to Poland and find out how your family is doing, which was very bad. They had all been murdered, or most of them. And he kept his mouth shut until probably the end of the 70s about this thing. Okay, that's a
Hold on
long.
one second, Peter. So we cut out there for a second. I don't know if it just summarize real quickly the last two sentences you said. Rothblatt took his
So,
leave of the Manhattan Project
yeah,
under false pretense.
Rothblatt was at a party and heard Leslie Groves say that the nuclear weapons that were being developed were not developed against the Nazis, but as a threat to the Soviets. And he was very disappointed by that because that's not why he had joined. Um, so he asked permission to leave, was given permission to leave on condition that he would not talk about this. And he didn't until probably the end of the 70s or so. And then he started to talk about this. Now, that's a long introduction to my point. The point is, he spent his whole life working on nuclear medicine. And nuclear medicine, part of that will can still exist without nuclear reactors. And I don't know exactly what substitutes there are. There are some, but I don't think that they're complete. And so I take my lead from him. If that was good enough for him, I'll go with that. The details are complicated.
I understand completely. Um, I'll just say briefly, because you've mentioned Oppenheimer several times, the movie was wildly at divergence with the reality. Um, and the first point was that the characterization, I found it offensive that they played Oppenheimer essentially as borderline neurodiverse.
You're breaking up.
The reality. Oh, can you hear me now?
Yeah, now I can.
Okay. Whereas in reality, the uh, fact was that Oppenheimer was a very well integrated, well adjusted, jovial person. And they used to say he was the life of the party who made the best cocktails. And so it's just a complete divergence with this kind of struck, uh, utterly like character throughout the movie.
Well, I don't know whether I agree. I read the book on which what was it called?
American
American
Prometheus?
Prometheus, and the picture you get from Oppenheimer isn't not necessarily neurodiverse, but I think it's sort of what in the old days people would call neurotic.
Oh, he truly had some neurotic moments.
Yes, yes.
And I don't deny that. But I think he just, in the movie, he's just so divergent from what is in a movie called The Day After Trinity. Have you ever watched that documentary? The Day After Trinity, they interview all the scientists and they're talking about how he made the best cocktails.
I know, and then yes, I must say, when that movie came out, I had just retired, and I gave a course at Ollie, the Osher Learning Center, and sort of continuing education at URI, and the course I gave was called "Everything You Didn't Learn Watching Oppenheimer, the Movie."
Nice.
Because there was so much that they left out. It was a Hollywood thing. Yes, entertainment, but in terms of what is really important to know, it was terrible. And
Mm-hmm.
also completely downplayed uh, what had been done in Nagasaki and in Hiroshima. Oh well, we destroyed the place. Shit happens, and it was an opportunity for a nice bang. It was very very disappointing. And Roadblock, my hero, was never mentioned. And this comment about the Soviets, which is even more important than Roadblood himself, which really colored history ever since, wasn't mentioned. So I mean that was completely sanitized.
Right.
Yeah, I find it very annoying. And as you say that the day after Trinity was the opposite. They interviewed these people who worked there, and I don't know whether you remember, what was his first name? Wilson, who
Yeah.
was with his wife,
Yeah.
and you could feel how how conflicted he was.
Right.
I mean, this was years after, and he started to cry almost,
Right.
and none of that was in the movie, right?
Right. Right.
And Bethe, same thing. Um, Frank Oppenheimer was interviewed, same thing. I mean, it was so much better from my perspective. I totally agree. Yeah.
And I just like, um, in general, I think the overarching point or argument of the movie was that, in a way, nuclear proliferation now is justifiable in some sense.
Well, I agree with that, and I'm sort of thinking, looking at the clock, thinking what else do we want to discuss? But the next item
True.
on menu, I think we sort of agreed on, was the Rhode Island delegation, and and they fit
Correct.
in exactly that pattern that you mentioned in many ways. Um, Should we move on to that subject?
Sure, let's go directly into that.
What's that?
Let's go to that because I think it's a good, at least understanding the reference to Oppenheimer helps us understand contemporary war appropriations because it's a lot of the same patterns.
Absolutely, absolutely. And we haven't learned anything from, just to make the connection even clearer. I did I mention the Frank report, or it just passed through my
No,
mind?
you didn't just, so
Well,
that's a,
the Frank report came out in, I think, June of 1945. And there's a lot of stuff in there, but the things that stuck with me is they Frank was one of the Nobel Prize winning scientists there, and he wrote a report with a bunch of other people. And one of the things they said, if we, the United States, set off a bomb and use it in the war, chances are that we will never succeed to put in place what it takes to control nuclear energy in a way so that mankind can benefit from it. And it is exactly what happened
yeah,
to this day. And the issue of the evil Siamese twin went back to the Lilienthal, Lilienthal report. Aikson and Lilienthal were people who talked to Oppenheimer a lot. So that particular report carries their name, but Oppenheimer wrote it. And again, on on basically page one, maybe I'm exaggerating, but in that report it says nuclear energy and nuclear bombs are two sides of the same coin. You cannot do one without the other. And our congressional delegation, and this is what I said at the beginning, they rank number one among the people who are working against proliferation as bad guys because they completely ignore that. In particular, Whitehouse, because he uses his status as climate champ to sell nuclear energy without ever doing it and never mentioning the dangers. So, okay, we'll get there. And I, I mean, it's clear to anybody who thinks about these things that Rhode Island is structurally tied to the Pentagon.
right.
You know, Senator Reid never passes up an opportunity to glorify his contributions to the Rhode Island war economy again and again and again. And as I said, that's about 10% of the whole. And that's a bipartisan issue, and it's not restricted to Rhode Island. And I think you used the term military Keynesianism or something like that, with a slightly different twist, but the same thing. You know, that's the only jobs program that has bipartisan support, the war economy.
Right.
Uh, Senator Reid is the chief architect of the submarine buildup that's happening in Rhode Island and along the East Coast, but also perhaps on the West Coast. I don't even know. But he has been a regular chair of the Armed Services Committee, and he pushes through one National Defense Authorization Act after the other, and then celebrates it by saying, "Oh, our men and women in uniform get a hike in their pay," which is typically not even enough to keep up with inflation. But it's pure PR.
Right.
Um, so there is electric boats that we all know where a lot of people work, and they make Virginia-class submarines. Well, some people call that a defense mechanism, but it's a nuclear-powered attack submarine that is capable to launch nuclear-capable cruise missiles. Not what
Right.
I call defense. It's an attack thing. I mean, yes, of course,
Right.
in the context of mutual assured destruction, they've managed to to blur the distinction between attack and defense in that crazy
Right.
world. Um, Senator Whitehouse takes his cues from Senator Reid. Anything Reid says yes to, Whitehouse says yes to, as far as I'm concerned. I think that that's a pretty good approximation of reality.
Yeah.
Um, but he goes further than that.
Yeah.
Um, well, the one Virginia-class submarines, and this is a literal quote. He considers it an important priority for the defense industry in Rhode Island.
Right.
Okay, I call it the war economy, to be clear, not to confuse matters. But he, as I said, uses his status as climate champ to push nuclear power. And he was one of the lead sponsors of something that passed in, I think, 2024 called the Advance Act, which
Okay.
was, I don't know where it's basically one of the last ones of many acts that he pushed. There was something that it was approved. It's called, well, let me see, the Nuclear Energy Innovations Capability Act. That was passed in September of 2018. The Nuclear Energy Innovation Modernization Act. I mean, these things are almost unpronounceable, but that passed in 2019. In all of those things, Whitehouse was a central player, or to make sure that this bipartisan legislation, sorry, that this legislation would pass. Um, and then more recently, so I mean, Advance and those two previous things, I've been aware of his role in that, and it's always with the people on the other side and saying, oh, and even the climate deniers on the other side say, oh, this is phenomenal for green energy. I mean, it's really comical at some level,
Yeah.
but um, because you can see how they say whatever works without any respect for truth or falsehood. If it works, it's fine. Anyway, what Senator Whitehouse has been involved in recently is goes back to this business of what we were talking about at the beginning about the reactors. He has been promoting reusing spent nuclear fuel, in particular coming from the Navy. And um, well, you can use spent nuclear fuel because because of the plutonium content it has. So you can take that stuff and chemically process it and separate out the plutonium, and that gives you something that you can use to run nuclear reactors on. So maybe it's not good for making bombs, but you can certainly speed up the whole nuclear infrastructure that way. And they make something out of it that's called MOX, MOX. It's mixed oxide fuel, which is a mixture of uranium 238 and 235 presumably, and also plutonium. And what Whitehouse demonstrates that he doesn't understand the basics because, well, either he's lying or he doesn't understand the basics. I can't tell the difference. But he is confusing that kind of reprocessing, in other words, taking out the plutonium and mixing it in with something else to get a nuclear fuel, with something called down blending. For instance, you have a lot of stuff that can be used for bomb making, and you say, well, look, that's 90%, but what we really need is 20% or 5%. Just mix in um, some of the uranium 238, and the percentage will go down, and we can use it for other purposes. That's called down blending.
Hmm.
Reprocessing cannot be used for that process for that at all. So, and he confuses it. I can point you to
Okay.
a press release literally wherein he totally confuses the matters, or whoever wrote that press release. They're clueless.
So not only is he, potentially kind of playing loosey goosey with nuclear apocalypse, he's totally clueless.
Yeah, in my book, it is probably clueless. I don't know.
Wonderful.
No, it's out there on the internet. Um,
That's wonderful. Just wonderful to know about Sheldon Whitehouse on top of everything else.
well, I don't know. He's never been my greatest friend. You know.
Yeah, we all know his nickname is Weldon.
Well, yes, I heard somebody else do a number on his last name and call him Outhouse.
Yep.
And
That's
I've called him
true.
Green, Greenhouse for a while. Uh,
I dig that. So, okay, we've talked about the congressional delegation. You talked about Jack Reed sending projects to Groton and Quonset as part of this Pentagon Keynesianism. Um, do you want to say anything about or any interactions you've ever maybe had with the War College as an entity?
Well, I know very little about it, but I think
Okay.
there's one thing that we should add to the story that the congressional delegation tries to sell us,
Okay.
which is based on work that was done by a professor at UMass. Robert Pollin is his name. I don't know whether you know his name.
Oh yeah, I know him.
Well, he's an economist, and many years ago, he asked the question: well, suppose I have $1, how many jobs will that generate in an economy when I use it for a military purpose, for clean energy, for healthcare, for education? And so this whole wonderful job creation program of our Rhode Island delegation completely falls flat if you look at those numbers. So
Right.
I'll read you the numbers. Military by definition is one. You know, that's the unit. So if you stick money into clean energy, you get 1.5 times the bang for your buck in terms of job creation.
Right.
Healthcare 1.6,
Right.
education 2.4, two and a half, almost 2.5 times the bang you get for your buck.
Right.
So they're selling us a dangerous game, and they're selling us lousy jobs or a
Right.
lousy way of spending our tax money to create jobs. So that's what I
And let me throw in there another.
say that
Let
again.
me throw in another number there. Can I throw in another number that's just another moral one for me? And it's the idea that it's been determined every food stamp dollar spent in the economy generates $1.79 in economic activity. And so let's be clear, we're prioritizing lower outcomes in a way that incentivizes starving children.
I could
In this,
I completely agree with you. Somehow that particular item didn't register on Pollin's radar at the time. This is old research, but
oh yeah,
in particular, the last couple of weeks, yes, I have read that statistic, and this whole business of the Rhode Island legislature and the so-called leadership that we have of focusing on the blue economy while letting people just they basically said, "Look, you have no food for a week. Well, who cares? I'm just going to continue eating." So yes, that I think is a moral outrage. I couldn't agree more with you. And yeah, thanks for mentioning that because it's an important thing.
yeah.
Now, okay, so the last thing, the Naval War College, I don't know what they do, but they're mostly if you go to their website, they call themselves a nonprofit organization. They get most of their funding federally. Guess from whom? From the Navy. From in
Well,
their
it is. Yeah,
it's
it's a private university.
a private university that basically gives the allure of respectability to wargaming, strategic research, uh, basically it's selling the war economy and making it look respectable. That's how I see them. But you know, I don't know their real work. You know, sometimes in those places, just as a token, they have somebody who studies nonviolent methods. I mean, it happens. I don't know
Yeah,
whether
right.
it happens there, but it does happen, and something useful comes out of that. So they
Yeah,
do war planning, war games, strategic doctrines, operational concepts, you name it. I'm sure there are interesting operations research projects that are based on this and how do you distribute your nuclear submarines across the globe.
right.
I
I
don't.
hear you.
I
So
it. I think it's a
yeah,
figment for the defense establishments. That's how I see it. You
yeah.
won't disagree with that.
I uh, I understand what your point is, and um, I think in structural terms of like these 2 points that I wanted to just bring up. Um, more than anything else because of historicity that people don't really understand. And I'm going to just read these two. Rhode Island was founded as a network of seaside plantations worked by slave labor, which is a vital component of the state's initial GDP. And it's important to emphasize that the state was founded on to uphold and protect slave trade as in the Bay because that's the genesis of capitalism in the ocean state. The Brown family then retrofitted their slave ships as military vessels and sold them to George Washington's Continental Fleet. The slave ship contains one kind of labor type, the slave catcher, and the military contains the soldier. So we have this very starting point for this conversation. What do you think about the idea of the Navy being built out of those refurbished Rhode Island boats and that level of history going that far back?
Uh, yeah, I mean, Rhode Island is of course not unique in that sense. I mean, I've been reading books about written by this guy called Russell Shorto. Who have you ever read any of his books? He started out a couple of years ago about he wrote a book, The Island in the Center of the World, and he stumbled upon records that the Dutch had left in New York City. And the Dutch were very much like the Germans in keeping meticulous track of everything they did. And so there's a wealth of information in there. And of course, then it goes on, and ultimately the British throw the Dutch out of New York City and call it New York.
Right.
And at the same time, on the side, they have wars going on with indigenous people. They have slaves coming into the harbor there, and slaves going to Rhode Island. The Dutch, by the way, in terms of original sin, I mean, I grew up in Holland to the extent that I grew up. Um, they basically were the ones who introduced the stock market to the United States. That came
Right.
from Holland with the early Dutch settlers.
Right.
So the ships and all of that. I mean, the Dutch had a really nasty uh, history with respect to the slave trade. They and the Spaniards, I think, were instrumental in that. Maybe even more so than the British. I don't know. It's hard to compare because there were always more British Englishmen than there were Dutch. So do you do it in absolute numbers or per capita? I don't know. But it's yeah. I don't
Yeah.
know. We live
I
with it's
we live in the legacies of these systems because the notable part for me in that anecdote is the inter uh, permutation between private sector and public coffer self dealing. The Brown family was extraordinarily uh, agile financially in the colonial economy. So, what they were setting up was one of the best self dealing mechanisms possible for their entire operation by selling retrofitted ships to a military that in turn, you know, was going to be of supreme benefit and protection to their own interests
yeah.
during the coming war.
I didn't know that they did that, but actually, the one thing that I thought I should mention and I haven't mentioned yet has to do with this. I mean, this whole colonial structure and the inequality across the globe that still exists today in big numbers shows up in what nobody in the U.S., at least nobody in Congress, ever mentions, and some people refer to it as energy apartheid. If you look at the amount of energy per capita that the US uses and you compare that to Pakistan or Bangladesh or you name it, any countries over there,
Right.
it's inconceivable how big that difference is. And so if you say we're, White House might say this, oh, we're going to run the economy on nuclear energy. Well, let's think that through. Are you saying we're going to do that as the US and we're bombing everybody else into oblivion who is not part of our world, which is probably the idea? Well, I would say it would be a better idea to create equality against the globe. And then suppose that you want to do that and you want to create energy equality across the globe. And you want to go ahead and say, well, the US is going to triple the number of nuclear energy sources that it has. And you do that across the world, you probably end up with 10 to 20 times as many nuclear reactors across the world. What do you think that's going to do to the risk of proliferation? Do you
Right.
ever hear that anywhere? Did you hear the governor mention that in his State of the State or anything like that? It's
No.
and that is part of this same attitude as the slave trade. At least I don't see much of a difference because the people who suffered from it then are the people who suffer from it now.
Right. And we also need to be real about the fact that let's imagine you have all these first world nuclear reactors that are generating energy. They, whether or not they generate material useful for a bomb, they still generate nuclear waste. And it is not beyond my imagination to see uh, nuclear company try to dump atomic waste into some forgotten Pacific atoll, something
Yeah.
like that. We already know they do it on indigenous lands, so they're pretty indifferent.
Well, go to the Marshall Islands, and there is this dome, which is
Bingo.
exactly that. As a matter of fact, they tried to clean up the Marshall Islands after these mishaps, and and then created a dome, basically a big structure with concrete on top. And while they were at it, they took a lot of the nuclear waste from Nevada and put it there too. So what you were predicting has already happened. And
Wow.
worse than that, actually, because of sea level rise, that dome is cracking up and that stuff is all coming out. And then they have no idea what to do with it.
Oh my God. Damn. Yeah,
Yeah.
I mean, my colleague and editor at Counterpunch, Joshua Frank, wrote a book about Hanford and the complete disaster that's waiting to become because of its own degeneration now after 75 years since it was opened as part of the Manhattan Project.
Yep. And guess who are fishing in the Columbia River for their sustenance? It's the indigenous people who are eating radioactive fish.
Correct.
It's the same story everywhere. And so, in that sense, your Brown story is an example of a pattern that persists. It persists in 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 Gaza in particular. I mean, that's another example of the same attitude.
Right.
Yeah,
Especially,
very upsetting. Um,
yeah, especially because they discovered an oil field off the shore, and that's much of the presumed motivation for trying to completely uh, cleanse the entire strip and have it reoccupied.
yeah, I know.
Uh,
There is this whole triangle: Egypt, Gaza, and actually they discovering new and new gas fields actually off the coast there. Um, and the relationships with Greece. And what is the name of this scumbag who resigned recently from the U.S. Senate? I don't know his name, but he was great in pushing legislation that made sure that nothing would get in the way of this in that part of the Mediterranean.
right.
And again, that's something that you rarely hear about.
Mm-hmm. Right. Right. So, do you have any other further points you want to bring up before I let you go?
No, I think I've done my share of talking and basically covered what I wanted to cover. I can send you some of the graphs that illustrate some of the things that I was talking about. Maybe a table here and there. If I don't know what format